Okay, ma. So the next concept which we are studying is analogy between heat transfer and electric current, ma. Okay. So already we studied that heat flow, water flow, and current flow, they are analogous to each other, no? So that analogy we will study, ma, because in solving the problems, this analogy will be very much useful for us. Okay. So see. So consider this is a metal, okay, a piece of metal, and here we are maintaining a potential difference of V1, and here potential is V2. No? What is meant by potential? That we will study in current electricity. Ma? So potential is nothing but work done per unit charge is called as potential. Okay. So it means that for an electric charge, for a positive electric charge, to move from one place to another place, potential difference must be present. If there is no potential difference, current cannot flow. Are you able to understand? Ma? Potential difference must be present. So if I want current to flow in this direction, current is represented by I, ma. So if I want current to flow in this direction, then definitely V1 must be greater than V2. This is one point which we should always remember. So current always flows from higher potential region to lower potential region. This we will study in detail while we study current electricity topic. Okay, ma? So always V1 should be greater than V2. Therefore, what is the amount of current that can flow? I is equals to V divided by R, and this is called as Ohm's law. Okay, ma? The amount of current flowing is nothing but the potential difference created divided by the resistance of this metal. Understood, no, ma? So potential V is called potential difference. No, this potential difference can also be written as V1 minus V2 divided by R also. So I can write this is the amount of current flowing if this is the potential difference between 2 points and where R is the resistance of this particular metal. Okay, ma? R is called what? R is called as resistance of this metal. Resistance means the ability of the material to oppose current is called as resistance. Are you able to understand, ma? To oppose the flow of current is called as resistance. Similarly, now I will try to write the analogy of this one in terms of heat conduction. So here also I am taking a piece of metal, ma. Okay, I am taking a metal piece. Okay, and here temperature is theta 1, or you can call it as T1 also. And at another end, temperature is theta 2, or you can call it as T2. Okay, now heat energy should flow from theta 1 to theta 2. So this is the direction of heat flow. Okay, ma? Then can you say what is the condition required? T1 must be greater than T2. That's all. No? So here if potential is greater than second potential, then only current will flow. Same concept here also. If theta 1 is greater than theta 2, or temperature here is greater than when compared to temperature at this position, then only heat will flow. Okay. And we study another term which is called as H. H is called as heat current. Okay, ma? What is meant by H here? H is called as heat current. So we know current, no, ma? Here current is represented by I. Here heat current is represented by H. Or for our understanding purpose, you better write like this also, IH. The heat current flowing through a conductor. Okay. And this heat current, H, how can I write analogous equation, ma? Can you say anybody? T1 minus T2 divided by, no, okay, no, R only. R only. Here resistance, here I will use thermal resistance. Are you able to understand, ma? So therefore, heat current is equals to theta 1 minus theta 2 divided by RT. This is how I can write. Are you able to understand, ma? Here R means resistance, here RT means thermal resistance. So that is the ability of the material to obstruct the flow of heat current. Our ability to disallow heat is called as thermal resistance. Okay, ma? Ability to obstruct the flow of current is called resistance, no? Ability to obstruct the flow of heat is called as thermal resistance. Okay. So therefore, what is RT here? RT is called as thermal resistance. Understood, Nama? So if you forget the equations here or how to do the calculations in the case of heat flow, then always you can compare this one with current electricity and you can do the calculations. Are you able to understand? Next, see. So in the case of resistance, we write R is equals to rho L by A. This is one formula of electric current. Are you able to understand, ma? R can be written as rho L divided by A. What is meant by rho? Rho is called as resistivity. Okay, ma? L is called length of conductor. A is called area of cross section of conductor. Okay, ma? Are you able to understand? So R can be written as rho L by A. Same resistance I can write it as L by sigma into A also. Okay. Now instead of rho, what I have written here, instead of rho I have written sigma. And what is meant by sigma? Sigma is called as conductivity. Conductivity. The opposite of resistivity. Conductivity indicates resistance of a material. Subbarao, Vinali. Okay. Conductivity indicates how good a conductor is, how easily it is able to transfer current. Okay, ma? And the relation between conductivity and resistivity is rho is equals to 1 by sigma, or you can write sigma is equals to 1 by rho. This is the relation. Are you able to understand, ma? Now, same concept I can write here also. Okay, let us see how I can write. I can write a thermal resistance is equals to, here I have written L by sigma into A, no, ma? Here I will write L divided by, now can you say instead of sigma what I can write? Sigma is conductivity. I can write coefficient of thermal conductivity K, no? Okay. So instead of sigma I will write K, K into A. So this is the equation for thermal resistance. Are you able to understand, ma, how we are trying to understand? We are trying to compare the analogy between electric current and heat current. Okay. Come on, make a note up to here. Okay. Now see, ma. So these are the calculations which we have understood by taking analogy, no, ma? Now let us try to understand what is meant by heat current actually. So here I know electric current, I is equals to V by R, or you can call potential difference divided by resistance, V1 minus V2 divided by R. Here I have written IH, RH, theta 1 minus theta 2 divided by R. Now let us have a small discussion about actually what is meant by heat current. Okay, ma? So heat current, H is nothing but Q by T. So this is the point which you should remember. Okay, ma? So the amount of heat energy flowing per unit time is nothing but heat current. Okay, amount of current flowing per unit time is called as heat current. Okay, already we studied in the last class the amount of heat flowing is equals to Ka theta 1 minus theta 2 into T divided by L. This is what we have studied. Now you say you take this T to this side. Okay, then it becomes heat current, so heat current is equals to Q by T. And what are the remaining terms? Ka multiplied by theta 1 minus theta 2 divided by L. Are you able to understand? Now let us manipulate this one. Let us try to write a relation between this R and this H. Okay. So therefore H also can be written as it is equals to Q by T. This also can be written as theta 1 minus theta 2 divided by L by K into A. Can I write, ma? So K into A, it is a numerator, no? So it becomes denominator to denominator. So denominator is L, no, ma? So denominator to denominator means L by K into A. Are you able to understand? So, and according to this relation, what is H? Theta 1 minus theta 2 divided by RT. So theta 1 minus theta 2 divided by RT. RT is nothing but L by Ka. That's what I have written, no? So satisfied, no? Are you able to understand, no? Therefore, heat current can also be written as Q by T is equals to, so theta 1 minus theta 2 divided by RT, where RT is called as thermal resistance of this conductor or of this metal in which heat is flowing. Are you able to understand? So you can derive the equation of thermal resistance from this equation also. That's it. Make a note. Okay. So then now we are studying about the applications of heat flow. So I want to calculate equivalent thermal resistance in two combinations, series combination as well as parallel combination. Okay, now see. For example, in current electricity you should have studied, no? For example, in 10th class also you should have studied, no, ma? For example, if these are two resistors, R1 and R2, which are connected in a series connection. Okay. Then equivalent resistance is, how can you calculate? Equivalent resistance is equals to R1 plus R2. This is how you do the calculation, no? Okay, ma? So, same in a parallel combination of two rods also, I can use the same relation. Okay, how can I use? Let us see. So therefore, consider this is one rod. Okay, ma? And there is another rod which is connected like this. So consider these are two rods. Ma. Okay. So here a higher temperature of theta 1, here a higher temperature of theta 2 is maintained. Okay. So I will write that theta 1 is greater than theta 2. Then heat energy will flow in which direction? So energy will flow in this direction, or I can call heat current will flow in this direction. Are you able to understand, ma? So here also I can use the same formula. Thermal resistance of first rod is RT1, thermal resistance of second rod is RT2. Then what is the equivalent thermal resistance? R equivalent is equals to RT1 plus RT2. So this is the same formula which we can use. Are you able to understand, ma? Okay. So actually here the total current flowing here, see ma, here in this circuit, if I amount of current is flowing, so same current flows through first resistor, same current flows through second resistor also, no? Because there are no branches which are present. Branches are not there. So what is the current flowing in first resistor? Same current must flow through second resistor also. Okay. Therefore, what I can say? Therefore, I can say or I will try to draw a circuit so that you can understand very easily. See, this is one resistor R1 and this is one resistor R2. And both of them, they are supplied to a potential of V. Okay, ma? What is the potential of the battery which we are supplying? V. Clear, no? What is meant by potential? Work done per unit charge. That you should not forget. To make charges to move in a circuit, we have to supply energy, no, ma? And that energy is supplied by the battery. Are you able to understand? So therefore, resistor, what is meant by resistor? It is a component which consumes energy. Resistance means any component which consumes energy. It opposes the flow of current. Fan is a resistor. Okay, ma? Bulb is a resistor. Anything which consumes energy, you can call it as a resistor. Okay? Now see. So this resistor, out of this total energy which you have supplied, it will consume some energy. And that is called potential consumed by this resistor V1. Similarly, second resistor also will consume some energy, and that potential is called as, V2. Clear, no, ma? So therefore, out of the total energy we have supplied, some of the energy is taken by first resistor, some of the energy will be taken by second resistor. So therefore, I can write that V is equals to V1 plus V2. I can write like this, no? Total potential supplied is taken by these two resistors. Supply potential and consumed potentials, they must be equal. This is called as Kirchhoff's voltage law. Okay, ma? What is the total potential supplied in a circuit and total potential consumed in a circuit? Both of them, they should be equal. Otherwise, law of conservation of energy cannot be satisfied. No? What is law of conservation of energy? Energy can neither be created nor destroyed. Just you have to convert energy from one form to another form. So what is the produced energy? Consumed energy also should be equal. So therefore, I can write V is equals to V1 plus V2. Understood, Dhamma? Now see. Now. See, ma. So according to Ohm's law, V can be written as I into R, no, ma? V can be written as I into R. So what is the current which is produced in this circuit? Let current produced in the circuit is I. So V can be written as I multiplied by resistance of total circuit is R equivalent. Okay, ma? Resistance of total circuit is R equivalent. Now what is meant by V1? V1 is nothing but potential consumed by first resistor, no? What is the current flowing through this resistor, ma? Same current will flow, no, ma? Because there are no branches. Divide avvadaniki scope ledhu kada, same current should flow. So therefore V1 can be written as I into, and what is the resistance of this resistor? R1. Clear, no, ma? Similarly, same current should flow through second resistor also, no? So current flowing is I, resistance is R2. I is common, no? So you cancel them, I and I. Then what is the value I am left with? I am left with same relation, no? R equivalent is equals to R1 plus R2. Okay. Same type of calculation I can do here also, no? In heat flow also, same type of calculation I can write. How I can write? Okay. So therefore, here also I can write V is equals to V1 plus V2. So I can write heat current multiplied by thermal resistance, equivalent thermal resistance. Equivalent thermal resistance can be written as, how I can write? I can write I into RT1 plus I into RT2. Same heat current will flow, no, ma? What is the amount of heat energy flowing in this conductor per second? Same amount of heat energy should be flowing in the second rod also. Same, you take the analogy here. What is the current in first resistor? Same current is flowing in the second resistor also. Same concept here also. What is the heat current flowing in this rod? Same heat current must be flowing in the second rod also. Okay. So therefore, heat currents, if I cancel, then what is the answer I got? I got RT, thermal resistance, equivalent thermal resistance of total combination. This is equals to thermal resistance of first rod plus thermal resistance of second rod. That's all. This is the equation which I will get. Understood, Nama? Okay. Similarly, we will try to do calculation for parallel combination also. So let us see. See, ma. So here, see, ma, here, what is V is V1 plus V2, no? And here V is compared with temperature difference. Are you able to understand, ma? Here I will take potential difference. Here I will take temperature difference. Are you able to understand? So how I can write? Let us see. So here temperature is theta 1, here temperature is theta 2. So definitely I can write theta 1 is greater than theta 2, then only current will flow in this direction. And temperature of the junction will be different, no? Temperature of the junction. Junction means what? The point where these two rods, they are meeting with each other, that is called as junction. So let that temperature is theta. Okay, ma? Temperature of the junction is theta. Then potential difference across the first resistor was V1, no? Similarly, what is the temperature difference across first rod? Theta minus theta 1 minus theta. So this is the temperature difference between first rod. And this is comparable with potential difference. Okay, ma? Potential difference in electric current is comparable with temperature difference in heat current. Are you able to understand? You better make a note of this point. So what is the note point I have to write? Note point is that potential difference in electric current is analogous to what? Temperature difference in heat current. Understood, Nama? Okay. So theta 1 minus theta. Now what about temperature difference in the second rod? Temperature difference in the second rod is theta minus theta 2. Here theta should be greater than theta 2, no? Then only heat will flow in this direction. Otherwise heat current cannot flow. So temperature difference in the second rod is theta minus theta 2. Understood, no? Clear? Now let us do some more calculation. What is the total temperature difference? Total temperature difference is how much? Total temperature difference is equals to theta 1 minus theta 2. Okay. And this must be the addition of temperature difference across first rod and temperature difference across second rod. Clear, no? So what is the temperature difference across first rod? Theta 1 minus theta. Temperature difference across second rod? Theta minus theta 2. Okay, ma? This is comparable with V is equals to V1 plus V2. Are you able to understand why I am writing like this? Okay, ma? In electric current, total potential, some of the potential is consumed by first resistor, some of the potential is consumed by second resistor. Or you can say potential difference across first resistor is V1, potential difference across second resistor is V2. So potential in electric current is comparable with temperature difference in heat current. They are analogous to each other. Are you able to understand? So therefore, total temperature difference theta 1 minus theta 2, no? So this should be the addition of temperature difference across first rod plus temperature difference across second rod, just like this equation. V is equals to V1 plus V2. Okay. Now if you do the calculation, again I will get theta 1 minus theta 2 only, no? So minus theta and plus theta, they will get cancelled. Again I will get the same relation. Understood, no? So everywhere current and heat flow, they are analogous to each other. But this is the point which you should remember. Okay, ma? In electric current, we take potential difference. In heat current, we take temperature difference. That's it. Fine. So make a note up to here, then we will study this parallel combination. Now see, so parallel combination. So first let us try to take the analogy of this combination in electric current. So see, so this is one resistor, this is another resistor, and this is another resistor, and this type of connection is called parallel connection. Clear, no? So here resistance of first resistor is R1, R2 and R3, and this is the total potential difference which we are supplying. Okay. So in series combination, Sima, in series combination, what was same? Current was same, no? Same current will flow through every resistor. even if 100 resistors are connected, through every resistor, same amount of current will flow in a series combination. But in parallel combination, potential difference remains the same. Okay, see here, what is meant by V here? It means that here if I take a potential to be 0 volts, okay, so here if definitely on this side it will be lesser potential or lower potential. So if I take potential to be 0, then here potential will be V volts. Understood, no? Because potential difference is how much? Potential difference is V. Are you able to understand? So reference, if I take 0, already we studied Nama, potential cannot be defined without a reference. So I take a reference 0 here. Then immediately here, there is a rise of potential of V volts, no, because battery is connected. Are you able to understand? And what does battery provide? Battery provides potential difference. Okay. So from here to here, there is no other resistor, no? Ikkada nunchi ikkada varaku resistor emanna unda? Ledu. So it means same potential is applied here also. Understood, Nama? And here if potential is 0, same potential will be applied here also, here also, here also. Because in between them there are no resistors, no? Here if it is 0, here also 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 it is 0. Similarly, here if potential is V, here also potential is V, here also potential is V. Understood now what is happening? So therefore, what is the potential difference across R1? V minus 0, V. Potential difference across second resistor, V minus 0, V. Potential across third resistor, V minus 0 is again V. So in a parallel combination, potential difference across every resistor remains same. But in series combination, current remains the same. That is the difference. So therefore here what I can write, in parallel combination, okay ma, potential difference across each resistor, potential difference across each resistor remains same. Understood, Nama? That is what is happening. So therefore, now let us see. But what about current, ma? If this total resistors, if they are drawing I amount of current from the battery, okay, ma? I amount of current. What happens to this I amount of current? It gets divided in 3 branches, no? Because same current when it reaches here, it will see how many branches? 3 branches it is seeing. Okay, so some of the current enters into this branch, some of the current enters into this branch, some of the current enters into another branch. Okay, so therefore, how can I write? Therefore, I can write total current can be written as I1 plus I2 plus I3. I can write like this, Nama. Total amount of current which is produced in the circuit, it is divided into 3 branches. So I1 plus I2 plus I3. Understood, no? Now let us write from here onwards. Okay, so again according to Ohm's law, we know I is equals to V by R, no? I is equals to V by R according to Ohm's law. So therefore, let us try to manipulate that equation. So I is equals to I1 plus I2 plus I3. I can be written as V divided by R equivalent. What is meant by R equivalent? Resistance of total circuit. Okay, ba? So there are some resistors, no? But I don't want individual resistors. I want the combination of total circuit. That is called as R equivalent. Okay. So this can be written as I1. I1. Same potential difference, no, across first resistor. But what is the resistance? R1. So therefore I will write potential difference is remaining same, but resistance will become R1. Clear? Similarly, what about second resistor? Here also V divided by R2. And in the third branch, V divided by R3. Potential differences are same, Nama, across every resistor. So you can cancel them. So what is the answer I got? 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is the relation I got for resistors, no, in parallel combination. Okay, ma? And same relation exactly I can use in parallel combination of rods also in heat current. Understood, no? So therefore, let us write the analogy in heat flow, ma? Heat flow. So here resistors, they are connected in parallel combination. No, here what I will do is I will connect 3 rods in parallel combination. Okay, ma? So these are the 3 rods which are connected like this. Okay. So if they are connected like this, is it series combination or parallel combination? No, this is parallel combination of 3 rods. Okay. Thermal resistance of first rod is RT1. Thermal resistance of first rod, second rod is RT2. Thermal resistance of third rod is RT3. Understood, no? So all these rods, they are maintained at same temperature difference of theta 1. and all the ends of all the 3 rods, they are maintained at a common temperature difference of theta 2. So therefore, here potential across every rod is same, no? Here temperature difference across every rod is same. Understood, no? Therefore, what I can write? Okay. So temperature difference across every rod remains same. Okay. And it is equal to how much? And it is equals to theta 1 minus theta 2. Okay. Understood, Nama? Now see. Listen very carefully. So here current was getting divided into 3 branches, Nama, I1, I2, I3. So here also heat current will get distributed in 3 rods. What is heat current? H1. So the amount of heat energy per unit time flowing through the first rod is H1. And in the second rod, the amount of heat current is H2. And in the third rod, the amount of heat current is H3. So therefore, what is the total amount of heat current which is flowing? So total amount of heat current can be written as H1 plus H2 plus H3. This is the total amount of heat energy which is flowing now. Okay. So therefore, H can be written as, I can be written as V by R. H can be written as temperature difference divided by resistance. That's all, no? So therefore, I will write theta 1 minus theta 2 divided by RT equivalent. What is meant by RT equivalent? Equivalent thermal resistance of these combinations. Understood, no? So this can be written as theta 1 minus theta 2 divided by RT1 plus theta 1 minus theta 2 divided by RT2 plus theta 1 minus theta 2 divided by RT3. That's all, no? Temperature differences are same, no? Okay, ma? Temperature differences, they are analogous to potential difference. This you should not forget. Therefore, what I got? 1 by RT equivalent is equals to 1 by RT1 plus 1 by RT2 plus 1 by RT3. Okay, just like the equation which we got in the case of parallel combination of resistors. Understood, Nama? That's it. Make a note up to here. These calculations are just for your understanding. Main point is that these formulae, these are what you are supposed to remember. Okay, in series combination it is R1 plus R2 plus R3, and in parallel combination it is 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Okay, ma? So we have studied previously equivalent resistance, no, ma? Now we will calculate equivalent thermal conductivity of all these rods. Each rod has a different coefficient of thermal conductivity. So first one, let us consider its coefficient of thermal conductivity is K1, and for second rod it is K2, third rod it is K3, and fourth rod is K4. So lengths of each of these rods, they may be same, they may be different also. Okay, length of first rod is L1, second one is L2, third one is L3, fourth one is L4, like this. So there are many number of rods. Are you able to understand, ma? And here, first rod, it is maintained at a temperature difference of theta 1, and the last rod, it is maintained at a temperature difference of theta 2. And consider theta 1 is greater than theta 2. If theta 1 is greater than theta 2, what will happen, ma? Heat energy flows from this side to the other side. So this is the direction in which heat current will flow. That's all, no? Okay. Now, because they are connected in series combination, thermal resistance of first rod, let it be R1, R2, R3, and R4. Okay. Then what is the total equivalent thermal resistance, ma? Equivalent thermal resistance is R1 plus R2 plus R3 plus R4. This is what I can write now. It is the sum of thermal resistances of all the rods, because they are connected in which combination? Series combination. Okay. And already we have studied that what is the formula for thermal resistance? R is equals to L by K into A. This is the equation, no, ma? Thermal resistance L by K into A. So therefore, now if I want to substitute in this relation, R equivalent is equals to, so R1 plus R2 plus R3, and it goes on like this. Okay. So equivalent thermal resistance, how I can write? I can write. So what is the total length of this combination, ma? Total length of this combination is L, no? So L divided by, similarly, for individual rods we have K1, K2, K3, K4. But what is the K value for total system? That I can write it as K equivalent. That's all, no? Instead of K, I am writing K equivalent. K equivalent means what? K value for total combination. Okay. Multiplied by area. See, here we are taking area of every rod to be same. Area means area of cross section of every rod is same. Okay, so A1 is equals to A2 is equals to A3 is equal to A. It means area of cross sections, they are equal. Understood, no? So therefore I will write A here. So this is the value for total equivalent thermal resistance. Okay, now R1, what is R1? Thermal resistance of first rod. That's all, no? How can I write? Length of the first rod is how much, ma? L1 divided by its K value is K1. Area of cross section remains to be A. So like this you can write all the values, no? Okay. Similarly I can write L2 divided by K2 into A plus L3 divided by K3 into A, and it goes on like this. Okay. So therefore area of cross sections, they are same number, so they will get cancelled with each other. Now what is the term I am left with? Okay. So I can write, I can take reciprocals, no? Okay, ma? Or I want K equivalent, no? So if I want a K equivalent, how can I write? This is equals to L divided by L1 by K1 plus L2 by K2 plus L3 by K3, and it goes on like this. Okay, ma? So this is the K equivalent of total combination. Have you understood how we got this one? Clear, no, ma? So K equivalent means the coefficient of thermal conductivity of combination of all these rods. So this is my equation. Okay, make a note. So here similarly we can write some cases also, ma? So first of all we will do one thing, we will write some cases, then you can copy this. See. So case is that if lengths are equal, so length of each rod we have taken differently, no? L1, L2, L3. If lengths are also, if they are equal, then how I can write? I can write K equivalent is equals to, okay, ma? See, ma, same relation, total L can be written as L1 plus L2 plus L3 like this, no? Total L is nothing but addition of all lengths only, no, ma? So divided by, and the same relation I can write L1 by K1 plus L2 by K2 plus L3 by K3, and it goes on like this. So if lengths are equal and if there are n rods which are present, then I can write n into L, no? N into L divided by L, if I take common, then I am left with 1 by K1 plus 1 by K2 plus 1 by K3, and it goes on like this. Okay, so L and L will get cancelled, so therefore K equivalent is how much? It is n divided by 1 by K1 plus 1 by K2 up to 1 by Kn if n rods are present. Understood, Nama? So this is one equation which I can write. Okay, and one more case I can write is if there are only two rods, if two rods are in series combination, if only two rods are present, then instead of NL I have to write 2L, no? 2L. So L and L again they will get cancelled. So what I am left with? I am left with 2 divided by 1 by K1 plus 1 by K2. Okay, and if I take LCM and do the manipulation of this one, then also I can write it as K equivalent is equals to 2K1 K2 divided by K1 plus K2. This is how I can write. Okay, ma'am? Are you able to understand? So this is the equivalent thermal conductivity if I take only two rods and length of both rods they are same. Okay, so you need not remember all of them. You have to remember this equation. K equivalent is equals to L1 plus L2 plus L3 divided by L1 by K1 plus L2 by K2 plus L3 by K3, and it goes on like this for any number of rods. Okay, make a note. Okay, ma'am. So next we study about parallel combination. Parallel combination. Okay, ma'am. What is meant by parallel combination we know, Nama. For example, this is one rod, this is another rod, clear, ma? This is another rod. Like this we are placing three rods in parallel. Okay, you can place any number of rods, ma. I am placing three rods. Okay, and here lengths of these rods they are taken constant, otherwise we cannot do the calculation. Lengths are taken constant. In series combination, what was taken constant? Area was taken constant, but here length will be taken constant. Okay, so length of this rod is L, length of this rod is L, length of this rod is also L. Thermal conductivity of this rod is K1, this is K2, and this is K3. Okay, so this is maintained at a temperature of theta 1, this one is maintained at a temperature of theta 2. Are you able to understand? So therefore, area of cross section of the first rod is A1, area of cross section is A2, and area of cross section is A3. Area of cross sections may be different, no problem, but the lengths should be same. Then only we can do some calculations. Okay, ma? And when rods, when they are connected in parallel combination, then how can you write the relation between their thermal resistances? Thermal resistances are R1, R2 and R3. How can you write a relation between them? 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is how you have to write now, if they are connected in parallel combination. So R can be written as 1 by L divided by K into A. This is the formula, no? Clear, no? So therefore, length is same, no? Length throughout the cross sections, it is remaining same. And instead of K, what I have to write? I have to write a K equivalent. And area of cross section, how I have to write? Total area of cross section, I will write A. Okay, and what is meant by A here? A can be written as A1 plus A2 plus A3, and it goes on like this. That's all, no? Heat is flowing through how much cross section, ma? This cross section, this cross section, this cross section. So total area of cross section A1, A2, A3. And if there are many rods, A4, A4, A5, like this we can write. Okay. So similarly, what about the second one? This also I can write 1 divided by R can be written as L by K into A. Length is same, no? So K value is K1, area of cross section is A1. That's all. So like this you write all of them. So plus 1 by L divided by K2 into A2. Clear, ma? Plus 1 divided by L divided by K3 into A3. Like this I can write. Okay. So lengths are same, no? So you can calculate, you can cancel all the lengths. Okay. Therefore, what is the final answer I got? K equivalent into A is equals to K1 A1 plus K2 A2 plus K3 A3. This is how I can write. Okay. So therefore, what is the K equivalent mass? So K equivalent is equals to K1 A1 plus K2 A2 plus K3 A3 divided by A. A can be written as A1 plus A2 plus A3. This is how I can write. So this is the K equivalent in which combination? Parallel combination of rods. Understood now? So here we will write some cases. What are the cases I can write? Okay. Case is if areas are equal. Okay, ma? If areas are equal. Areas of each rods, if they are equal, then I can write A1 is equals to A2 is equal to A3 is equal to A. I can write like this now. So if all areas are equal, then what I can do? I can take A common. Then it is K1 plus K2 plus K3 divided by, here I have 3A, no? 3A, or I can write NA. N into A. If there are n terms. Understood, no? So here also I will write up to Kn. If n terms are present, divided by n into A. So n get cancelled, no? So therefore, what is the K equivalent? So it is K1 plus K2 plus K3, and it goes on up to Kn divided by n. Understood, no? So this is the K equivalent if n number of rods, they are connected in parallel combination. Okay. I can write again one more case, no? Only if 2 rods are connected. If only 2 rods are connected, K1 plus K2 by 2, that's all. So K equivalent is equals to 2 rods. K1 plus K2 divided by 2. Because mostly up to Neet level, he will give questions only on 2 rods only. So better you remember K equivalent is equals to K1 plus K2 by 2. Okay. And general formula is this one. This is the general formula. You can use this one for any number of rods. K1 A1 plus K2 A2 plus K3 A3 divided by A1 plus A2 plus A3. Fine. That's it. Okay. Sima. This is the question. So there are 2 identical rods, same size rods. Area of cross section, length, everything is same. Okay. So they are connected in which combination? Series or parallel? Series combination, because what is the current flowing in the second rod? Same heat current will be flowing in the second rod also. Clear? One end it is maintained at a temperature of 100 and other it is maintained at a temperature of 0. So therefore, this is the direction of heat current. Heat current will flow in this direction. So after steady state is reached, steady state means what? Steady state means after some time, we have already studied that temperature of every cross section of the rod will remain constant. That's what we have studied now. So if you take this cross section, it may be at 80. If you take this cross section, it may be at 60. And those temperatures, they will remain to be same. That is called as steady state condition. Okay. Now he is asking us to find out temperature of the junction. So let the temperature of the junction is T. Okay. How we can solve? See, already we studied that heat flows just to how current flows and just to how water flows. No? Clear, no? So therefore, what is the amount of heat energy which is passing through this rod? Same amount of heat energy must be passing through the second rod also. That's all. And what is the formula for heat energy? Let it be Q1, let it be Q2. Definitely I can say Q1 and Q2, they must be equal. Clear, no? Current also flows like this also, no? Are you able to understand? Therefore, what I say, so Q value, how can I write, ma? Q value, Ka into theta 1 minus, or you can write T1 minus T2 into T divided by X. This is equals to Ka into T1 minus T2 multiplied by T divided by X. Okay. Area of cross sections, they are same. Time taken is also same. Okay. And lengths also they are same, no? X values are also they are same. Now what are the terms which are variable here? K value is variable, no? So what is the K value of first rod? 300. Now what is the temperature difference across first rod? 100 minus? 100 minus T. Temperature of junction we have written, no? This is the temperature difference across first rod. You are saying temperature difference across total combination. Are we doing combination here? No, single rod I am taking. So therefore, 100 minus T. Okay, still what are the terms? That's all. So this is equals to K. What is the K value of second rod? 200. Temperature difference is T minus 0. Now can't you calculate T value from this one? That's all, that is our answer. Clear, ma? So do the calculation. So 0, 0, 0, 0 will get cancelled. So 300 minus 3t is equals to 2t. So therefore 5t is equals to 300. So 5 6 are 30. So 60 degrees Celsius. So temperature is 60 degrees at the junction of the rods. Understood now? So this is one method of calculation. Okay. Any other method? Same problem can be done in another method also. So we will study method number 2. Okay. See, my rods, they are connected in series combination or parallel combination? Series combination, no? So it means what is the heat current that is flowing through first rod, same heat current must be flowing through the second rod also, because analogously, if two rods, if they are connected in series, same current will flow, no? So heat current also will be same. So therefore I will write H1 is equal to H2 is equal to H. Okay. And what is the formula of current? We know that I is equals to V by R, no? I is equal to V by R. So in terms of heat current, how can you write? Okay. In terms of heat current, how can you write, ma? I is equal to V by R. So V is nothing but temperature difference, no? Potential difference is analogous to temperature difference. Is it clear? So what is the temperature difference across first rod? 100 minus 60 T divided by thermal resistance of first rod. That's all, no? This is equals to temperature difference across second rod, T minus 0 divided by thermal resistance of second rod. And we know the formula for thermal resistance, no? What is the formula for thermal resistance? L divided by K into A. That's all, no? This is equals to T divided by L divided by K into A. That's all. So what are the terms which are constant? L, it is constant. A also, it is constant. Okay, ma? So K goes to the numerator. 100 minus T into K1 is equals to T into K2. That's all. Again, you do the same calculation. Then again, you should get T is equal to 60 degrees. That's it. Okay. So what is the second method we have adopted? We have adopted Ohm's law. I is equal to V by R. Okay. Because they are connected in series, same current should flow. So current flowing in first rod, current flowing in second rod, both are same. And we know the formula of thermal resistance, no? R is equals to L by K into A. Just we have applied it. Okay. See, ma'am. So here, see, in foreign countries, the temperature of the climate will be very cool, no? So they will use heaters also. So in winter season, they will use air conditions, and in summer season, in winter season, they will use heaters also. In every house, not almost, in every house, cooler will be there, that is air condition also will be there, heaters also will be there. ఇక్కడ మనం హీటర్స్ పెట్టామంటే పోతాం పైకి. There heaters will be there because temperature of the climate is very less, no? So see here, outside temperature of a house is minus 5 degrees Celsius And inside the room, they want to maintain a temperature of 30 because that is approximately the temperature of body normal, body temperature. So in the house, 30 degrees, and outside temperature should be, it is -5. Therefore, in this wall, so heat will travel through the walls only, no? So this is the construction of a wall, a brick wall. On the brick wall, a layer of cement coating will be there, no? Cement coating is present. And on that cement coating, a layer of wood is also present. So in America, people mostly, the rich families, they construct houses with the wood only. Are you able to understand? Ma? So these are the 3 layers which are present. Now the question is, to maintain the same temperature in the room, what should be the power of the electric heater they should use in that house? Are you able to understand? First of all, why I have to maintain temperature, ma? Because this is at a higher temperature, this is at a lower temperature, no? Definitely heat energy will continuously, it will be moving out of the room. Continue, this is the direction, no? Heat energy will flow in which direction? Heat energy will flow in this direction. This is the direction of heat current. Higher temperature to lower temperature. So continuously temperature will be reducing. So we have to use the heater to heat up the room. Are you able to understand? So he is asking the data about power of electric heater. So we will do in first method. Okay, ma? What is meant by power, ma? Power formula? Force into velocity, you can say. One more formula. One more formula. Work done by unit time is called power, no? Work done per unit time is called power. Work is also called as energy. Energy per unit time. Energy is also called as heat energy also. No? Clear, no? So Q by T, that is the ratio which we are supposed to calculate. Are you able to understand? So therefore, Q value, how can I calculate? Q value, K into A into theta 1 minus theta 2 into T, already here it is present, divided by L. This is the formula I have to use, Nama. L means total length of this wall. Length of the wall is 2 centimeter plus 1 centimeter plus 20 centimeter. So, but here it is given in watts, Nama. We will convert this one in terms of meters. So total how many meters? 23 meters, 23 centimeter. Okay. And here, what is K value, ma? K value for individual layers, it is different. But I want K value of total combination. Are you able to understand? How can I calculate K value of total combination? First of all, is it series combination or parallel combination? Series combination. So because this is a series combination, do you remember the formula of K equivalent? 3 na. First, let us say the total formula. L1 plus L2 plus L3 plus dash dash divided by L1 by K1 plus L2 by K2 plus L3 by K3, and it goes on like this. This is the formula we have studied, no? So how many layers are there? 3 layers are there. So add all of them. So first layer is 2 centimeter, 1 centimeter, 20 centimeter. So if you write in SI system, what I will get, ma? So 23 multiplied by 10 power minus 2 meter. That is the total length, no? Divided by, now you have to write individual lengths. Individual length is 2 centimeter. 2 into 10 power minus 2 divided by K value is how much? K value of wood is 0.150. Okay, ma? Plus, like this you can do total calculation, ma? I am not doing this one. Okay? So do this total calculation, take this value and substitute here. Okay? Then I will get power, no? K I calculate from this method. Area of cross section of each wall, area of cross section of wall, 150, that is already given. Temperature difference is already given. Temperature difference is 30 minus of minus 5, 35. That is the temperature difference. Clear, no? And the length, what is the length of total wall? Again 23 into 10 power minus 2 meter. This is first method of doing the calculation. Are you able to understand? Okay. Any other method? Now you can do this one, no? Just to calculate K equivalent, substitute in this one, you will get the answer. First method. Second method of doing the same calculation. Second method. Okay. So dq by sigma. Current power is nothing but Q by T. Okay. And this is also called as heat current, no? Energy flowing per unit time is called what? Heat current. Okay. So heat current, how can I write? Heat current, for example, in a current electricity, I is equal to V by R, no? So heat current, I have to write a temperature difference divided by thermal resistance or equivalent thermal resistance. I can write like this, no? Do you remember? Current flowing is I is equal to V by R. Heat current, voltage potential difference is analogous to temperature difference. So theta 1 minus theta 2. Here resistance, here thermal resistance. That's all, no? And heat current is nothing but Q by T, no? Q by T is nothing but power. So therefore, heat current is nothing but power of the electric heater. Understood now? Now see, so theta 1 minus theta 2 already I know, 30 minus of minus 5, 35. So let us write here. Theta 1 minus theta 2 is how much? 35 minus minus 5. 30, no? 30 minus of minus 5 is 35 degree Celsius. That is the temperature difference. Okay. Now equivalent thermal resistance, do I know, RT equivalent, is it given? No, I have to calculate. Okay. So is this series combination or parallel combination? Series. So what is the formula of series combination? Series. Series. So R equivalent is equals to R1 plus R2 plus R3. This is the formula of series combination. So you know what is the formula of R, no? R is L1 divided by K1A1 plus L2 divided by K2A2 plus L3 divided by K3A3. Areas are same, 150, but L values are different, K values are also there different. So calculate this R equivalent, substitute here, you will get the heat current. Heat current is nothing but power. That's it. That is the second method of calculation. Understood now? Very simple. Okay. So values I will write down now, you check them. So heat thermal resistance you will get 2.26 into 10 power minus 3. Okay, ma? So 2.26 into 10 power minus 3. Units are per degree Celsius divided by watts. Per degree Celsius divided by watts. That is the thermal resistance. Okay. And if you calculate the power, power should be 15.49 kilowatts. Okay, ma? Power, how much you should get? 15.49 kilowatts. That is the answer which you should get. Clear? Kilo means 10 power minus 3, ma. So be careful about the lengths, ma. Lengths they are given in CGS system. They are given in centimeter. Convert them into meters. Okay? So these are the two methods in which I can do this calculation. See, ma. So this is the question given, ma. 3 identical rods. It means length, area of cross section, breadth, everything is same. So they are arranged like this, ma. And 3 ends of the rods, they are maintained at different temperatures. 4 degrees and 12 degrees Celsius. I want to calculate what is the temperature of the junction. Okay, ma. So let us assume junction temperature is T. Okay. Now the point is that heat energy, it flows in which direction? Can you say? Downwards direction. It enters into which rod to which rod? Adi naku kavalsinde. Steel to copper. What about aluminium? Steel to copper. Steel to copper. Next? Steel, aluminium, aluminium, copper. Steel to copper, steel to aluminium. Sima. So in current electricity we have studied junction rule, no? Junction rule. What is junction rule? So consider, so this is the current which is entering from one wire, 5 amperes of current. So this current will be distributed in these two wires, 2 amperes of current and 3 amperes of current. Current can be distributed like this. So what is the junction rule? Current entering a junction, this is the junction, no? Current entering a junction must be equal to current leaving a junction also. That is current rule, junction rule. Okay, or you can call node rule also. So let us write that rule first of all. Okay, so current entering a junction should be equal to current leaving a junction. Okay, ma? This is understandable, no? So therefore, if current is following this rule, heat current also will follow the same rule, no, ma? So total heat current which is entering into this junction, and heat current will enter in this direction. This is the direction in which heat current will flow. Why? Because 50 is at a higher temperature, no? And 12 and 4, they are at lower temperature. So heat current entering like this, this is H. So this gets divided into both the rods. Are you able to understand, Amma? So here H1 current will flow and here H2 current will flow. So therefore H is equal to H1 plus H2. This is the equation which I have to write. Understood, no? Some of the heat enters into aluminum also, some of the heat enters into copper also. Clear, no? Heat gets divided in both the rods. And now what is the formula for heat current? I is equal to V by R, no? No? So therefore H can be written as theta 1 minus theta 2 divided by RT, thermal resistance. Clear, Nama? So here also you write theta 1 minus theta 2 divided by R1 plus theta 1 minus theta 2 divided by R2. So in the first rod, that is this rod, what is the temperature difference? 50 T. So 50 minus T divided by thermal resistance formula, L by K into A. That's all, no? And in the second rod, what is the temperature difference? T minus 12 divided by L by Ka. Plus third rod temperature difference, T minus 4 divided by L by K into A. Rods are similar, Noma. So therefore L value, K value, L value, K value, L value, K value, they will get cancelled. Understood, no? So therefore, now just we are supposed to do this calculation. So 50 minus T divided by, K values are given, no? K value of steel is how much? 200. This is equals to T minus 12 divided by, oh sorry ma, this is 1 by K, no? K is present in denominator, no ma? So it goes to the numerator. Okay? So I have to write K into 50 minus T, and this is for which one? This is for T. So this is equals to K into T minus 12, and this is for aluminium. And K into T minus 4, this is for copper. Okay? Now just substitute all the values. Okay? K steel 200. 200 multiplied by 50 minus T is equal to K aluminium 200. Adi 200 na? That also 200 ona. Same I have written for both of them. Let me check my once. K of steel is 50 ma. K of steel is 50. 400 and 200. Steel is a bad conductor, no? Its K value will be lesser. Aluminium and now it is okay. Okay. So K value of steel is how much? K value of steel is 50. So this is equal to K value of aluminium 200 multiplied by temperature difference is T minus 12 plus K value of copper 400 multiplied by T minus 4. So 0, 0, 0, 0, only 1 0 will get cancelled now. So this is 40, this is 20, and this 0 will get cancelled. So now you have to do this calculation. 5 5 is 25, so 250 minus 5T is equal to 20T minus 12 2s are 24, 240 plus 40T minus 160. Okay? So do this calculation and see what is the value we will get. Do it. 250 plus 240 plus 160 is equal to so 20T plus 40T plus 5T. That's all, no? This is 400, 650. So 650 is equal to 60, 65T. So T is equal to 10 degrees Celsius. 10 only, I think it is correct. Okay? So temperature of the junction is how much? 10 degrees Celsius. That is our answer. Okay? అంటే ఈ రాడ్లో హీట్ ఎనర్జీ